Okay, you can unmute yourself, Mr. Usman.
Assalamu alaikum.
Alaykum salam wa rahmatullahi.
Good day, doctor. Thank you very much for this presentation, as always. So actually, I have a question, even though it's not directly related to this class, but it's related to the of Weka.
Okay.
So I don't know if you have closed the Weka screen or it's still on.
Yeah, it's on. Yeah.
Okay. So actually, let's assume we finish the modeling and we already obtained our actual and predicted values. You showed us how to get those values in Weka by simply like clicking more options, and then you ask it to show you the output values.
Yeah.
So my question is yes. So like simply clicking more options, and I think clicking the output value, you get the actual versus predicted values.
Yeah.
So my question is, can we export it directly to Excel, because sometimes we need the actual versus predicted to create some kind of plots. So normally what I do is like when I try to copy it, it will not give me it as different cell. It will give me like 3 different numbers in the same cell. So I have to like manually split the numbers into different cells and then proceed with anything that I want to do in Excel. And there was a time when I had a lot of models. So what I did was I took all the values. And I put them in individual Excel files. Then I gave someone to help me with Python. So he kind of split the data for me in Python.
Do it procedure. Okay, that's your question,
yes. Yes, so I don't know if we can directly export it to.
Okay, sorry, that's actually, sorry for that. That's a very long way to solve the problem. You see here, you can. I hope you can see the Weka environment. Can you see it? More option, eh?
Yes, yeah, I can see it. Yes.
Okay, just click the more option. Actually, the idea is this is output prediction. Usually, by default, it is set to null. Null means don't output the prediction, because some people don't need it. So in order to reduce the number of volume of information that will be, imagine if you have like 1,000 samples, it's going to display 1,000 samples on the screen. You have to scroll down before you see your result. So because of this, it is set to null by default. So you just go here, you choose the option you want. You can actually export it directly to CSV file, which is like Excel file. See? Just click output prediction to CSV file. Then it will prompt you to select the pair you want to save your result, and then you go and take your file there after you are done. CSV file is just like Excel. Then you can then take it. You can see here, these are the options. See, go from here, output prediction, choose. You have option here, CSV, HTML, in memory, plain text. You want it to be in plain text, XML. The default is null. So you can select CSV, and then it will save it in the current directory where you are running your Weka from. Then you can pick your result from there. So hopefully that will solve the problem. Okay?
Okay.
Yeah.
Inshallah. Thank you very much.
Barakallah fiik, eh?
Normally, I think before I use plain text and then I pick it up, take it to Excel, but now I will try it.
Yeah, exactly. Next time when you face such a challenge that will make you to go and be typing result one by one, so you can try to get across, you get the point. Usually we have a principle in computing, so when any task is becoming too tedious, no, we are not doing it the right way. There should be a way to make it easier. You get the point, eh?
Yes.
So there's always going to be a way out, so you can always reach out for clarification. So I wish you all the best, eh?
Thank you very much, Charlie.
Yeah, you're welcome. Yeah, so clear, because we have a few minutes more to have another engagement. Mr. Muhammad.
Assalamualaikum.
Walaikum salam.
Thank you very much, sir, for the section.
You're welcome.
I want to ask regarding the hyperparameter tuning. As we are doing it manually, that like we pick one, we try to change the other. Is there a way in Weka that we can use like maybe the random search or grid search?
Okay, yeah. So there's a grid search option in Weka where we can say the grid search. So there's a grid search option in Weka. If I'm not mistaken, maybe we had a video on this earlier, I'll double check, but however, apologies because of a kind of another appointment I'm going to have now in a few minutes' time. We will not be able to demonstrate that research, but I will try to see if we can demonstrate by next week by the grace of God. Okay. So if it's not already in the videos or already uploaded, if it is, we will share it with you or in the platform. Otherwise, we'll demonstrate how you can do grid search. We can have a way of setting up grid search for any of them. Yeah. The advantage of grid search is so you can search for all parameters, but then it could be very cumbersome. It could be time consuming. So that is why. And then also it takes that flavor of understanding what is going on is taken away from the user, especially for a starter. But for someone who's already very conversant with it, it's okay to go with the grid search. So, and like I said, the grace of God, we try to demonstrate it in our next edition. Okay? Thank you.
Okay, thank you, sir.
You're welcome. And there's a last questioner there we're going to be taking today. AI.
Yeah, Assalamu alaikum, sir, Prof.
We'd like to know your name, if you don't mind.
AI is Dr. Hamid Mosaku.
Oh, my big brother, how are you, sir?
I'm the love kind. AI is my initials.
Okay.
Isa is AI.
I thought artificial intelligence, eh?
Yes, also. So we use it like that.
Okay, good.
Because of no time and your next engagement, sir.
Yeah.
Two things.
Okay.
The 30% after the cross-validation exercise, when we bring in the data set into the whole modeling, that's one. Number two, sometimes ago we discussed something like MIMO, multiple input, multiple output, but the demonstrations were not done.
Okay.
So maybe subsequently, practically, how can we achieve that too? That's just the two from my end, sir.
Okay. Okay, thank you very much, sir. So, yeah, we look into quickly on the first question, and that is, see, in case we divide our data into 70, 20, 30, or 80, 20, it can also be 80, 20, some people does that. So we bring that in and use it for training, and also, for hyperparameter optimization, and then finally, that same value that is already we now use for training of our system. This time around, so we're going to use to train the model. When we train the model using that 80% or 70% as the case may be, now we have two ways of bringing in the data. One way is to use this. You see, you can see this option up here. We can see this option up here. Use supplied training data. We can decide to bring in this 70% after we have used it for the hyperparameter optimization. We have gotten the best parameter. Now we now bring it in because we want to use splitting into test training and testing only. We don't want to use co-validation for the final model. Then you now say, okay, use training set. To set you to use you have to bring in this training set afresh. Then when you train the model, you now say supply testing set. That 30% that you have been keeping outside the weaker, this is where you are going to supply the testing set. You now set. Then you are going to open it here. Only that 30% or 20%, you can bring it in here. So you are going to go into where the data set has been kept, open it, and then once you open it, then you can click start, and then it will start testing using the model you already built. So this is how we can achieve that one. Thank you. As for the second question, yes, having multi-input is normal. In the normal case, this is what we have been doing, multiple input. But multiple outputs, except you automate it, in most cases, multiple output and usually handle one after the other, because it's believed that there are different variables we want to see, and then we want to, the modeling, no single algorithm will handle two variables at the same time. Even to be able to model one variable is hard enough. We struggle to get it performing. So handling two variables does not really work. So what happened is, If there is any package that does multiple output, it is just programming. They will do the first one, then they will do the second one, then the result will come out together, as if they are doing it at the same time. It's not being done at the same time. Because the way modeling takes place, identify hypothesis function has to be for one single variable, one output at a time. Two output cannot be done at a time. But then we can automate it. Once we identify the hypothesis function for one, we go to the second, we go to the third, then we combine the results, we send them out as if they're coming as individual. But the secret is every output is modeled separately, individually. So I hope that clarifies, Doctor.
Yes.
Okay. Thank you very much, sir. So, Mr. Salami, so last question.
Thank you for the time.
You're welcome.
Yes, sir. My question is very brief, sir. Due to the time constraint, I did a machine learning modeling on educational data mining recently, and my support vector machines algorithms, hyperparameter outcomes were the C was 20, and the kernel was a polykernel. So I was worried that the C 20, is it not too much for the parameter tuning?
You mean seed, eh?
Yes, C. The C gave me, that is, C gave me the highest accuracy.
Okay,
So
C as in cat.
Yes, sir, C.
Okay, that is a regularization factor, C, yeah.
Yes,
it is not too much. It's not too much.
Okay.
Sometimes you can get 100. It depends on the data set. Sometimes we can use 1,000. It depends on the data set, actually, and the nature of the data set. Sometimes our data set is very stubborn. You have to increase the value more before you can get reasonable result. But we always make sure
there's no
don't get much value. Yeah.
Oh, thank you. It's no implication for higher values.
Yeah, sometimes when if it gets, because support vector machine is a very strong system. Yeah. So, like I said, we are going to treat hyperparameter optimization of support vector machine by the grace of God next week. We'll talk of some of the implication of if one value is too high or it is too low. Okay? Inshallah. Okay. So, but the value you have gotten is not too much. Yeah. It depends on the data set. Just remember the principle of let the data speak. In as much as after you have gotten this, your result is not over. There's not the overlearning does not take place. In which case, overfitting does not take place. In which case, you get like 99% in training, and the testing says like 30%. That is overfitting. So in that case, your C is too much. Your regularization factor has been extremely toned. So in that case, we have to adjust it. But it rarely happens in support vector machine. It usually happens in neural network and others, but overfitting is very rare in support vector machine, but it is possible. It depends on the data set you are modeling. But for 20, you have to look at the actual result of your training set and testing set. If they are still within reasonable range, that should still be fine. Okay.
Thank you, Prof.
You're welcome.
I really appreciate the clarification, sir. May Almighty reward you in abundance.
Thank you very much. And you too, and everybody. Thank you very much. Yeah. So
yes, Prof. Hello, Prof. This is Dr. Mojisola, sir.
Okay.
Please, just a take home for me, and at the same time to correct my mindset. I am just believing that this issue of having default value, perhaps we in engineering, when we manufacture or produce a machine, we believe that we produce such a machine with the highest value as our default value.
Yeah.
And I'm thinking that will it be correct, or I'm not too sure that most of the cases the default value might likely give us one of the best results, if I'm not mistaken. Thanks so much, sir. Just to correct my mindset.
Thank you very much. Thank you. Exactly. This was the assumption of the student. You get the point. Now, I give you why in data analytics it cannot hold. In your own system, you have built a model. Yeah. Don't build your own model, your machine, you optimize it. So you have a default value. Your default value is the best value for on what you have optimized it for. And luckily for you, you are going to use that machine to solve the same problem everywhere. Maybe drilling machine for drilling. But sometimes also, that is why it failed, because the nation of the land differs. But it's already fixed for a particular default system. That is why even new machines that are being produced now, they are being automated in such a way that they allow it to be tuned in real time. If you are drilling rock and you are drilling normal sand, we should not use the same energy, the same power. But if the machine is already fixed, like you said, I agree, from the manufacturer, it has a default value. That is the problem of hardware, because it's fixed. However, since algorithm, what I also noticed is, in the case I faced recently, the students were using support vector machine for a problem, and actually the default parameter for that SVM was fixed to be polynomial. Sorry, for the kernel, it was RBF, which is Gaussian membership, the Gaussian kernel. Now, in reality, Gaussian happened to work for a lot of problems. Yeah, like you said, in most cases, you see Gaussian value working fine. However, in data analytics, we call something let the data speak. I always mention this. We have had a solution, a problem whereby Gaussian crash landed. It's only polynomial that works. There are other several cases like that also. But for those people who build that algorithm, they notice that in most cases, RBF will work. Let's put it there. It is now upon you. They have only put while they develop. Other guys might have experienced that. For our own case, out of 20 experiments, 17 of them already always perform better in polynomial. If you come across the SVM written by those people, they will use polynomial as their default. Another guy use RBF as their default. But then, as somebody who pick up these functions and you want to use it, and you understand the principle of data science that let the data speak, then you need to do optimization. For example, for C, they put C to be 1. Now you can see the previous speaker said he got C of 20 already. They made C to be 1, permanent. C of 1 might not work for many problems. And in their cases, because they were getting, actually the result they sent to me, the student, they were getting 86%, 75% for support vector machine, and KNN was getting like 96. I said, KNN can get this. Support vector machine is supposed to perform. I said, did you do upper optimization? They said, no, we use default. I said, no, it's not fair. You see, it means for that data set, default was not working for support vector machine. And you cannot force it to work for it. So that is why, since it is a software, you have to tune it. It's not already hardware that is built that you don't have the capability. Even now, like I said, new hardware that are coming out, they are giving people the opportunity to change the parameters instead of giving them the default values. I hope that clarifies why we need to do the tuning.
Yes, Prof. Thanks so much.
Hello, Fig. Wish you all the best. Thank you very much all for listening. This is what we are going to have for today. There's Brother Yakubu Aminu. If you are there, so you can chat with me, please, after the class. So yeah, I wish you all the best, and thank you very much all. Till next week, inshallah, when we're going to meet. Have a very nice weekend. Bye.